Morning. Good morning to all of you. Welcome to our session. Today in this session we'll be discussing complex analysis. So complex analysis, one of the largest topic of mathematical methods, and generally you get a question from this complex analysis in each paper. That is why this becomes very important. That is why this topic becomes very important for your examination. Now, previously we have covered multiple chapters, and today we will start complex analysis. I will share the solution of the homework problem on the WhatsApp group. You can check it from there. Today, let's start with complex analysis. And one thing I would like to tell you, that the previous lecture number 23, which has gamma and beta functions, have been already shared to the course folder, so you can watch that from your course folder. Let's start with complex analysis. We will start with the basic definition of complex numbers and how they are represented. So without any further ado, let's start. Complex number and its representation. Do you know how complex numbers are represented? Look, if you have a complex number in general, a complex number z is represented as z is equals to x plus iy. Now, as you can see, there are two parts. One is this x, another one is I times y. So this is the real part of the complex number, and this y is the imaginary part of the complex number. Now, if you have a complex number z, the complex conjugate is represented by z bar. The complex conjugate z bar is represented as, you already know, when you take the complex conjugate, we replace I by minus I. So it will be z bar equals to, x is a real number, so x minus I y. Clear? Good morning, Ajay. Look, now any complex number z can be written in the form of modulus times its phase. So if you have the complex number z, it can be represented as its modulus times its phase, e to the power I theta, let's say. Now, polar form we can consider to understand this. Polar form means in terms of r and theta. So the real part x in polar form is written as r cos theta, y is written as r sin theta, and the modulus is given as, how to represent the modulus of z. This is equals to actually r root over x square plus y square. Good morning, Murli. Good morning, Thamij. This theta you can also find out using these two expression, x equals to r cos theta, y equals to r sin theta. So that theta is called the argument. So this is the modulus of z is mod z. Now there is a term the argument. Argument of z, it is represented by arg of z is equals to theta. So what will be the value of theta? It will be tan inverse y by x. No issue in this. And as you can see it from clearly that this modulus z is nothing but x square plus y square whole square. Okay, x square plus y square. If you just remove this root, you get r square. What does this thing represent? What does this thing represent? X square plus y square is equals to r square. This represents a circle, na? It represents a circle. So x square plus y square is equals to r square. What we can write from here? Mod z equals to r. So mod z equals to r, what does it represent? Mod z equals to r represents a circle centered at the origin and having radius r. Okay, this is the meaning. So if I show it here, you can say that if this is your x axis, this is your y axis. This part is very crucial, guys, for your conceptual development. This part is very crucial. Try to understand it. In the xy plane, x square plus y square, what kind of graph it is? It is a circle centered at the origin like this, and whose radius is 1 unit, sorry, let's say general r. So this is the origin, this value is r, radius r. Now if you consider any point on this circle, let's say P xy, so this is that xy, x and y, r cos theta plus r sin theta. So this angle is theta, right? Now as you can consider, as you can see here, what is this? This is x, so this is your r cos theta, and this much is your r sin theta. This is your r cos theta, this is your r sin theta. Is it getting clear or not? So this graphical representation you need to understand. I hope this is clear to everyone. Let me give you some situation. Let's say if you have mod z minus 1 equals to 1, can you draw this equation. Firstly, what will be the form of this equation? What does it represent? Mod of z minus 1 equals to 1. What does it represent? It represents a circle. Okay. Now mod of z minus 1 means where does the center lie for this case? Can you tell me? Where does the center lie for this circle? So first of all, this represents a circle of unit radius. Whatever mod you see, then on the right hand side whatever you see, that is the radius. So okay, this is x, this is y. So its center will be at z is equals to 1 here. Zero, 1, 2. Understood? This represents mod z minus 1 equals to 1. Let us say mod z plus 1. Mod z plus 1 equals to 1. So this also represents a circle of unit radius. So for that thing, what will be your form? How will you represent the graph? So you see what is happening. Z plus 1, whatever thing is given to you, you will make that thing equals to 0. So previously what we take, mod z equals to 1, so z is equals to 0. You know, the origin lies at z equals to 0. For this, you see z minus 1 is there, so you will make z minus 1 equals to 0. So your origin of the center of the circle will lie at z equals to 1. For z plus 1, the origin will lie at z is equals to minus 1, right? So z plus 1 equals to 0 you will do, then z will be minus 1. So if the origin is lying at z equals to minus 1, so this will be the equation. Is it clear, guys? Now the same equation, if I say that mod of z plus 2 equals to, let us say, half. So this represents a circle of radius half. So how will you draw this? Try to draw by yourself, then match with my answer, okay? Draw it by yourself. Look, this has z plus 2 equals to 0, so z equals to minus 2. So here the center will lie, but now the radius is also half. So this is, let us say, -3, so it will come up to half. So this will be reduced. Center will be at z is equals to -2 and radius will become half. Tell me guys if it is clear. This is a very fundamental concept. You will be utilizing this many times in the upcoming problems. One more, let's take this was asked to me in some interview, I think, if I remember correctly. They gave me z plus 2 equals to 3. Can you draw this? Z plus 2 equals to 3. Deep, Murli, Thamij, Ajay, Harry, just try to draw this. If you can draw this one, then it means you have understood the thing. So the center will be around z equals to -2, but the radius you can see it is 3 unit. So -3, -4, let's say this is -5. So this will become bigger. It will be centered at z is equals to -2, but it will go up to z is equals to +1. I think it will you are getting my point, no? Although the space allotted here is not sufficient to draw this, but it will be centered at z is equals to -2 having 3 unit radius, 1, 2, 3. Clear guys? This concept is this clear? This is 3 unit. And one thing you know, whenever we represent a complex number, let us say x plus iy, let us say this is y, this is x. So this is the real axis, okay na? This is your real axis, this is your imaginary axis. This is the origin. So if you represent 1, 2, 3, then you can represent like 1, 2, 3 and so on. Now what does it represent? Z is equals to, let us say, 1 plus I. So you go real part x, then y, this is I, 2i, 3i and so. So 1 plus I is this point, this is your 1 plus I. If I say z is equals to, let us say, 2 minus I, where does this point lie? 1, 2, this is minus I, minus 2i and so on. So 2 minus I will be here. If you consider, let us say, z is equals to minus 2 plus I, so this is minus 1, minus 2, 2 plus I, so here z is equals to minus 3 minus 2i. So it will be minus 3i 2i. So here will be this point minus 3 minus 2i. Understood? Let's name them z1, z2, z3, z4. So this is your minus 2 plus I, this is your z1, 1 plus I, this is your z2, 2 minus I, this is your z3, minus 3 minus 2i, this is your z4. Is it clear, guys? This concept must be understood very clearly, otherwise you will get stuck at every problem. Now give a little heading here. We represented, this is called complex number. Now a similar thing is the complex variable, a function of a complex variable. If you have a function of a complex variable, so you see z has x and I, x and y both part. You will have written x, z equals to x plus iy. So if there is a function f of z, so it will have combination of x and y. So if you have, let's say, f of z, this is a function of complex variables. It will have a real part u of xy, this is the real part, plus I times v of xy, this is the imaginary part. Okay, this u of xi, this is the real part of the complex function, and v of xi, this is the imaginary or complex part of the complex function. If I give you an example, let's say f of z is equals to z square. So z square means what? X plus iy whole square. So what do you get? X square plus iy square means minus y square plus 2ixy, a plus b whole square formula. Okay. So here this x square minus y square, this is your real part, plus I times this 2xy, this is your imaginary part. This part is your real part, this part is your imaginary part. Is it clear, guys? Let's move on. If it is done till now, is there any question? चलो आगे बढ़ते हैं. Let's talk about de Moivre's theorem. I think all of you have read it in class 12. De Moivre's theorem. Do you remember that? De Moivre's theorem. In Boolean algebra also, na, we have this one kind of de Moivre's theorem. So as per the de Moivre's theorem, we have this form: cos theta plus I sin theta whole to the power n. This is equals to cos n theta plus I sin n theta. Okay, you have to remember this one, this de Moivre's theorem, mathematical form. Now let me give you some of the important relations which will be very much necessary in dealing with complex numbers and complex analysis. First of all, this e to the power I theta, e to the power I theta, this can be represented in terms of the complex numbers. What is this? This is cos theta plus I sin theta, okay, e to the power I theta. Then your cos theta, how do you represent it in terms of the complex numbers? E to the power I theta plus e to the power minus I theta divided by 2. This we are going to use many times. You have already known this, but let me just give you for the sake of completeness. E to the power I theta minus e to the power minus I theta divided by 2i. Now cos hyperbolic theta, cos hyperbolic theta is e to the power theta plus e to the power minus theta divided by 2. This is not related to complex, but like very similar formula to as cos theta, but here there is no I, only e to the power theta, e to the power minus I theta, e to the power minus theta divided by 2. And sin hyperbolic, just for your reference, it is e to the power theta minus e to the power minus theta divided by 2. There is no I or anything. Clear? Now, if we take a limit of a function, complex function, let us say f of z, z tends to z0. So, what is the condition that this limit will exist? Existence of limit z tends to z0 f of z. Any idea, guys? What is the necessary condition for the existence of limit f of z, z tends to z0? So it is like you have a z0 point and you are approaching towards that point z0. That is the meaning of limit, right? So the limit will exist only if the value is independent, of the path along which z approaches z0. Means either you take this path or some other path, you reach to z0 via this path, or you reach to z0 via this path, or this path, or this path, or this path. For all the paths, the limit value will be independent, the value will be independent, then you can say that this limit exists. Okay. Okay, for an example, let's take an example. Let's check whether the limit, let's say z tends to z0, limit z tends to, let's say 0, z by mod z, whether it exists or not. Can you check it? Limit z tends to 0, so it's approaching towards z is equals to 0, z by z mod z, does it exist or not? So if you look at, let's say I'm just trying to draw it so that you understand it graphically. This is your x axis, this part is your x axis, and this is your y axis. So along x axis you go like 1, 2, 3 and so on. Along y axis you go like I, 2i, 3i and so on. This is the origin. So z equals to z0 means you are approaching towards this origin point. So any number, let's say z is equals to x plus iy, this is the general complex number. Where does it lie? Let's say it is lying here. You go x along x axis and y along y axis. So this is your, this point represents z equals to x plus iy. So z tends to 0, what does it mean? Limit does not exist. Okay, let's see. It means you are approaching towards x tends to 0 and y tends to 0, right? So for z is equals to 0, we have to choose a path through the origin. We have to choose a path through the origin. This is z value, any z, so z approaching towards 0. So we can take up, let's say this path, we can take up, let's say this path. For the time being we are taking this path. Along this path you are going from z to z0. So what is the equation of this path? You know, this is a straight line passing through the origin, so this will be given by y is equals to mx, right? So we don't have space. Where should I write? Okay, let's write it above here. I'm just showing it for you here. So if I take up this path to reach z tends to 0, what result will I get? So z tends to 0 means x tends to 0, y tends to 0. Z is equals to, you know, x plus iy, modulus of z root over x square plus y square. No issue in this. So limit x tends to 0. Let's say we know the value of y equals y equals to mx, so let's put that. So x plus I mx. Now y value we have replaced, so there is no point of writing the limit of y, divided by root over x square plus y square. So this will be x square plus m square x square. Can you write it? So from numerator and denominator, if you take x common and x cancelled, so what you get, 1 plus im divided by root over 1 plus m square. Now, is this thing independent of the path? Tell me guys. In the definition I told you the limit will exist only if the value is independent of the path along which z approaches z0. But as you can see, the limit is depending on the value of m. M is what? M is the slope. M is the slope. So if you take up this path, then m will be different. If you, let's say, you can go to this path from any point, like you can reach to this path via this path, you can reach to this path via this path or this path. So there may be 100 and 1000 infinite number of paths through which you can reach to point z equals to z0. But if you take this path, you will get 1 m. If you get this path, the m will be different. Okay, it depends upon tan theta. So this is not independent of the path. So that is the limit depends on the slope of the straight line. Thus, the limiting value is dependent on the path. And hence the limit does not exist. Limit does not exist. I hope you can write it clearly, see it clearly. Let me know once it is done. Deep, Jay, Hari, Murli, Thamij, have you guys understood this one? Let's solve a problem now then. Let f of z equals to real part of z square plus imaginary part of z square by z square. Then which of the following is true? Can you do this problem? Real part of z square plus imaginary part of z square divided by z square. So what is z square? Z square we have already derived the x square minus y square plus I times 2xy. This was z square. So real part of z square is x square minus y square plus imaginary part of z square, that is 2xy. So this is the expression. Let's check for the first option. Limit y tends to 0, y equals to 0, x tends to 0 of f of z. B or a B let's see B will be the option or not. Y equals to 0 if you put, so what you get, x square divided by x square, right? So that is 1, but in the option it is given -1, so this option is not correct. Let's go for the next option. Limit x equals to 0, y tends to 0, f of z. X equals to 0 you put and y tends to 0, so this minus y square divided by x equal to 0, y tends to 0, so minus y square again. This is +1, no? The -1 is given, this is not the correct option. Let's check the third one. Limit y is equals to x and x tends to 0, f of z. This will be what? Y is equals to x. So the first term is 0, 2x square divided by, wherever you see y or x, you put them equal. So let's say wherever we see y, we are writing x. So the first term is vanishing, 2x into x, 2x square, and here also I times 2x square will come. This first term is 0. So this is 1 by I. 1 by I means minus I, but here it is plus I, so this is also incorrect. So obviously this option will be correct. Let's check that. Limit y is equals to, acha, that is what we have checked now, minus I, so this is the correct option. Tell me if you have understood this small problem or not. Have you seen a device in the fair, village fair or somewhere? You must have seen, or you must have seen in YouTube shorts also, some kind of metallic wire is kept in this form, and you are asked to pass through a structure like this, through this path, right, safely, and you are not supposed to touch the metallic wire. If this instrument, if this device touches the wire, then it beeps, you know. Have you seen this thing in various village fair or somewhere else? In fair generally you see this kind of thing. Then you do it like this, you safely pass it through the wire, and as soon as it touches the wire, it beeps, because you see, you make the conduction path and it beeps. Why I am saying this? The next topic that is quite related, complex analytic functions. So why do I say this? It is like, let's say you have this complex plane, we have y axis, we have x axis. So if you define a function, let's say f of z. Now Mr. Bean, yes, one of the videos of Mr. Bean, it was there. So the value of this function f of z at a different z will be different, right? Now the function value will not be finite at each and every point. There may be some point where if you put that value, it becomes diverging. Diverging because means infinity. Let's say one example I am giving you. F of z is equals to, let's say, 1 by z minus 1. So you take z equals to 0, z equals to half, z equals to 3 by 2, any value you take. this value of f of z will be finite, but as soon as if you take z is equals to 1, this denominator will be 0 and that makes f of z undefined or infinity, you can say. So at z is equals to 1, we can say the function is not analytic. This is the meaning. So what is the mathematical definition for this? So it is like you are checking this function at each and every point. So almost in all the point it is finite, but at some 1 or 2 or 3, maybe it depends on the nature of the function, it is giving you some diverging result, it becomes infinite. So at those point we say that this function is not analytic, at other point it is analytic. Okay. So at z equals to 1 it is not analytic, but at z equals to 2, 3, 4, any point other than that, that will be analytic. For an example, if I say f of z is equals to, let's say, 1 by z minus 1 and let's say z plus 1. So it has 2 points where the function ceases to be analytic. At one point is z equals to 1, another point is z equals to minus 1. Either you put z equals to plus 1 or minus 1, this function will be divergent. So it has 2 points where the function is not analytic. So I hope you have understood this one. So a function f of z is said to be analytic at a point z equals to z0 if it is single valued and has the derivative at every point in some neighborhood of z0. Now if I consider a domain, then you can say the function f of z is analytic in a domain D if it is single valued, you know the meaning of single valued, and is differentiable at every point of z. Okay. So how will you check whether any point, at which point the function is not analytic? What you gonna do? Singular point, those are singular point, yes. How will you check whether at which point the function has non-analytic point? So what is the condition? The condition is that this denominator is becoming 0, then f of z is becoming infinite, right? So you will set the you will set the denominator equals to 0 and you will find the value of z. That z can give you, let's say, 1, 2, 3 or 1 plus I, complex number also it can give you. If it gives you z equals to 1, then it will be on the real axis. If it gives you z equals to 1 plus I, it will be on the imaginary axis, and so on. So you will set the denominator to 0. Let's say if I say that the domain is a circle, let's say. So let's say this f of z has a singular point or the point where this f of z is becoming diverging. This is the point. Now, if you take a region like this, so within this region the function is analytic or not. If f of z has a singular point where the function is becoming diverging at this point, but if you consider this region, at this region the function is analytic or not. Obviously this is analytic, okay na? The region does not include this singular point. Now, related to this, there is a check. The check is done by Cauchy-Reimann equation. Mathematically, you check it by CR equation or Cauchy-Reimann equations. So, there are two equations for this. For a function f of z, for a function f of z u plus iy to be analytic at all points in some region R, there is two conditions. One is necessary condition, another one is sufficient condition. So, what is the necessary condition? This necessary condition you need to remember. Necessary condition is that del u by del x, this should be equals to del v by del y, and del u by del y equals to minus del v by del x. Clear? Sometimes it is also written in this form, ux is equals to vy. So, this means derivative of u with respect to x and derivative of v with respect to y, or it is written as ux equals to uy equals to vx. In this way also sometimes it is written. So, this is in Cartesian coordinate. The same thing can be written in polar coordinate also. In polar coordinates, the equations take the form, you see, del u by del r is equals to 1 by r del v by del theta. You can remember it in this way, you see, u 1 by r you have, theta is dimensionless. So, here on the left hand side the dimension 1 by r, so here we have 1 by r, and the second condition is del u by del theta is equals to minus r times del v by del r. You can remember it in this way, you see, on the left hand side you have del u by del theta, so both are dimensionless, theta is dimensionless, so this quantity should be dimensionless. But here you see del v by del r, r is coming in the denominator, so you have multiplied with r. So, in this way you can remember del u by del r 1 by r del v del theta, and del u by del theta is equals to minus r del v by del r. This is the necessary condition. What about the sufficient condition? this necessary condition you have to check whether the function is analytic or not. Sufficient condition is this: del u by del x, or del u by del y, del v by del x, or del b by del y. These are continuous functions of x and y. Continuous functions of x and y. Now let me give you a trick. Using that trick, you will be able to figure out whether the function is analytic or not very quickly. Special trick to identify whether the function is analytic or not. Look, we have seen that z is equals to x plus iy, no issue, है ना? Z bar complex conjugate of this is x minus iy. What is real of z? Real of z means x. Imaginary of z is y, है ना? We have seen this. So you see, any complex number, any complex function, let's say, which contains z will be analytic in nature, whereas any complex function which contains, let's say, z bar, real part of z, imaginary part of z, will not be analytic in nature. Okay. For an example, if I give you an example like this, 1 plus x minus iy whole to the power 5. So if you start with, if you go to check this thing with cauchy-reimann, then that will be very difficult. Tell me whether this will be analytic or not. 1 plus x minus iy to the power 5, is it analytic in nature or not? Not analytic, because you see it is 1 plus z bar, na? So it contains z bar, that is why this is not analytic. Now if I give you let's say x plus iy to the power 4, okay, 2 minus x minus iy cube, will it be analytic or not? this function, these are functions, okay. The first function, let's say f of z, this is another complex function. The second function, will it be analytic? So you see x plus iy is z to the power 4 2 minus z cube. So it contains z, so this is analytic. Okay. If it contains, let me set up one example. Let's say x plus iy minus 2y, let's say. Will it be analytic or not? Third example, x plus I minus x plus iy minus 2i, this will not be analytic because this contains z minus 2 times imaginary of z. So it contains imaginary of z, so that is why this is not analytic. So you have understood how to check up this thing. Okay. Derivative of f of z, how do you calculate this? So first of all, you know f of z is equals to u plus iy, right? So f prime of z will be del u by del x plus I times del b by del x. So if I take derivative with respect to x, you get del u by del x equals to I times del b by del x. Now from Cauchy-Reimann equation, you what is this value? Del u by del x is equals to del b by del y, and del b by del x is equals to minus del u by del y, है ना? So you can write it in this way. Let's try a problem. This came in June 2018. What is the value of a for which f of x y equals to, this thing is an analytic function of complex variable z equals to x plus iy. Do it quickly and tell me the answer. option D or option A? Check your calculation. Option A should come. So from this you can separate u. What is your u of xy? That is 2x plus 3 times x square minus y square, and v of xy is equals to 2 times 3xy plus ay. Cauchy-Reimann conditions. Option A is coming now. Ux is equals to uy and uy equals to minus vx. Ux is equals to vy, sorry. So if you take ux, 2 plus 6x is equals to vy, 6x plus 2a. So a equals to 1. Option 1. Now do it quickly, this problem. I think now you are very much strong in this concept. Which of the following is an analytic function? You have to find out the analytic function of the complex variable z equals to x plus iy in the domain j mod z less than 2. Look, what is the meaning of mod z less than 2? Mod z less than 2 means, you know what is mod z equals to 2? Mod z equals to 2 is a circle centered at the origin having radius z is equals to 2, है ना? Roughly like this. So mod z less than 2 means these inner points, this region. This region is your mod z less than 2. So I told you the trick. So the first option, you see, 3 plus x minus y, so 3 plus z bar to the power 7. This is not analytic. Z bar containing, not analytic. B 1 plus z to the power 4, 7 minus z cube. This is analytic containing z. Option B. C, you see 1 minus 2x, so 1 minus 2x, you can say 1 minus x minus x minus iy, so that is z. 3 minus z cube. So although it contains z, but it also contains real part of z. If it have real part of z, that is not analytic. It should only have z, then it will be analytic. X plus iy, so z minus 1 to the power half. Now this is an exceptional case, although it contains z, but this half factor, there is a something called branch point. You know, this is a multi-valued function. Say multi-valued function. This one we will discuss at the end of complex analysis lecture. Okay. This requires a special lecture for this branch point and branch cut. We will talk about that. Multi-valued complex function having a branch point at z is equals to 1. This branch point is a kind of singularity, and because of singularity at z equals to 1, this function is not analytic. Okay, understood? Correct option is option B. Now there is something called harmonic function. What is harmonic function? Harmonic function are those functions which satisfy the Laplace's equation. Okay. Option C. Option C, yes. Option C you can write 1 minus 2x is there, so minus x minus x minus iy. Can you write it? 3 minus x minus iy cube. 1 minus, to make it z, what you need only one x, so x is real part of z minus x plus iy, so this will be z. 3 minus, if you take common, x plus iy, so z. So as it contains real part of z, it is not analytic. Clear now, Murli? Let's move on. Let's go for harmonic function. The definition goes like this: any function which satisfies the Laplace's equation is known as harmonic function. Any function which satisfies the Laplace's equation is known as harmonic function. Now you see, if u plus iv is an analytic function, then both u and v will satisfy the harmonic, satisfy the Laplace's equation. If let us say u plus iv is analytic function, is an analytic function, then u v will satisfy the Laplace's equation, and they are called conjugate harmonic functions. Conjugate harmonic functions. Conjugate harmonic functions, both u and v will satisfy the Laplace's equation. Del square u by del x square plus del square u by del y square equals to 0. This is for u, and for v, del square v by del x square plus del square v by del y square equals to 0. है ना? So you can write it as a note that what is u? U is the real part of the complex function. What is v? V is the imaginary part of the complex function. So we can say that the real and imaginary parts of a complex function satisfies the Laplace's equation, and they are called conjugate harmonic functions. Is it done? Let's try this problem. Let u of x y is equals to e to the power x cos by be the real part of the function f of z equals to this of the complex variable z equals to x plus iy. A, b are real coefficients, constants, a not equals to 0. The function f of z is complex analytic everywhere in the complex plane if and only if. Tell me the answer quickly. What you gonna use here? Let me give you a hint. You know u, so what you can do, u satisfies the Laplace's equation, right? Because provided that the function f of z is analytic, so its real and imaginary part will satisfy the Laplace's equation. So if u satisfies the Laplace's equation, then from that you can find out the value of this b and a. You can find out a relation between b and a. You can do it in 30 seconds, guys, this problem. Since f of z is analytic, its real part, because real part is given, u is given, na? U of xy will satisfy the Laplace's equation. Therefore, del square u by del x square plus del square u by del y square equals to 0. Can you write it? So let's take double derivative with respect to x. So e to the power x, that makes us this calculation very easy. So 2 times a will come, a square e to the power ax cos by, and del square u by del y square. So this will, first derivative will be minus b sin by e to the power x, then minus b square cos by. Okay, a square minus b square e to the power x cos by equals to 0. You see this other part is 0, non-zero. So a square minus b square should be equals to 0. Option B you are getting? Yes. B is equals to plus minus a. Option B. Look, if you have the concept, you can do the problems very easily. If you don't have, then you will not be able to do it in most of the cases. Yeah, this kind of problem you can expect in your examination. This is your type, like u will be given as it is given in the question, the real part of the analytic function f of z, you have to find out the imaginary part, or the reverse may be given, imaginary part is given, you have to find out the real part. How will you do this? What is the approach? As it is already informed that it is an analytic function, it means it will follow the cauchy-reimann condition. Now del u del x is equals to del v del y. So if you know u, from this equation del u del x equals to del v del y. If you know u, can you not find out v? Because two relations you have, del u del y minus del v del x. So from these two equations, will you not be able to find out v? Give it a try, then we will solve. Option A. So let us use the cauchy-reimann condition. Cauchy-reimann equations, we have del u by del x equals to del b by del y, and del u by del y is to minus del b by del x. Let us use the first equation, del u by del x equals to del b by del y. So, what is the value of del u by del x? It is 1 plus x equals to del b by del y. So, from this you can write v is equals to 1 plus x times dy. So, integration of dy is y plus integration of x dy means xy. So, you have to multiply some integration constant. So, you are taking integration with respect to y. So, your integration constant will be function of x. This thing you try to understand. We are writing g of x, this is an integration constant. We are taking integration with respect to y. So, the integration constant will be function of x. Is this clear or not? Because y is variable. So, whatever constant will come, that will come in terms of x. Let us say this is equation number 1. Now, you use this one del u del y equals to minus del v by del x. So, if you take derivative with respect to y, what you get? Minus y, right? Minus y equals to del v by del x. So, from this what do you get? V is equals to xy. Now, you are taking derivative with integration with respect to x. You see y delta x. So, we have got xy. So, we are taking derivative with respect integration with respect to x. So, the integration constant will come as a function of y. Now, as you compare equation 1 and 2, what can you conclude? Compare equations 1 and 2. You see, from equation 1 v has xy is common. So, there is no doubt that xy will come because in both equation you have. Here it says that y will come, and here it says that there will be something which is a function of y. So, what is that? Y is there. Now, v says there is no x component, but here v says x component is there. So, we can conclude that g of x is 0. You know? So, the correct option is option A. Is it clear or not? Tell me. If anyone has any doubt, you can let me know. We have just compared equation 1 and 2. Xy, there is no dispute about xy. Then in 1 we have g of x, but in 2 there is no g of x. So, under what condition it is possible? If one place we are seeing g of x, another place no g of x. So, it is possible when the value of g of x is 0, and from 2 you can see the function of y is there, and in 1 you see there is a term called y. So, that will be your y, because both the condition must be satisfied. Del u by del x equals to del v by del y, and del u by del y equals to minus del v by del x to be an analytic function. Clear, guys? Let us move on. Try solving the next question. Consider f of z is equals to e of xy plus iv times xy to be an analytic function in domain D. Which one of the following options is not correct? Not correct. C is not correct. Chalo, f of z is an analytic function. So you satisfy the Laplace equation in D. This is correct. We have seen it. V satisfies Laplace's equation in D. This is also correct. We have seen it. F of z between z1 to z2 is dependent on the choice of the contour between z1 and z2 in D. So if this is analytic, then it only depends on the initial and final points, not on the path by which you are taking that function from z1 to z2. So this is incorrect statement, and that is what you have to find out. The incorrect statement is correct. If fz is analytic, then it can be Taylor expanded in D. That is also correct. So option C is the incorrect. Let's move on. Let's talk about power series expansion of a complex function. So if you have a complex function, it can be expanded in power series. We will be talking about Taylor series expansion, Lorentz series expansion and all. So every analytic function can be expanded in power series. Every analytic function which is analytic at z is equals to z0, let's say, can be expanded into power series. About z is equals to z0, so if you expand f of z about z is equals to z0, so we can write n is equals to 0 to infinity n z minus z0 whole to the power n. Option C, if fz is analytic, then z1 to z2 fz dz depends only on the paths at z1 and z2. It depends only on the initial and final point, the value of z1 and z2. It does not depend on the contour between z1 and z2. Means if you have z1 here, z2 here, this integration value will depend on z1 and z2 only. If you take up this path or this path or this path, for all the paths the value of the integration will remain same. So it is independent of the choice of the contour between z1 and z2. Got it, Harry? In vector also this kind of thing we have considered for conservative field. The value of the line integral depends only on the initial and final point. So it's like similar like that, provided that this f of z is analytic. Understood? But in the question it is given it is dependent on the choice of the contour, so that is incorrect. It should be independent. Dekho, if you write f of z as summation n equals to 0 to infinity a n z minus z0 whole to the power n, it can be written as a0 plus a1 z minus z0 a2 z minus z0 whole square a3 z minus z0 whole cube and so on, where z0 is the center of the power series. Now there is a concept called radius of convergence. Radius of convergence of power series means we have to identify in which region the function is converging. So let us consider a circle about z is equals to z0. Let us consider a circle at z is equals to, let us say, z0. This point we are calling z is equals to z0, right? And let's say the radius is r. Capital R. Consider a circle centered at z is equals to z0 and radius r. So how will you write the equation of the circle? If it has center at z equals to z0, means z minus z0 equals to r. This will be the equation of the circle, such that the power series is convergent for all points of the region. What is the opposite case? Divergent means if it happens that at one point that function is becoming infinity, then you can say the total domain is not analytic. There is a point which makes the function non-analytic, so such that the power series is convergent for all points of the region. All points of the region. You see, z minus z0 equals to r. What does it represent? It represents this circle, right? This circle, as you can see. Now, if it is z minus z0 less than r, what does it represent? It represents the inside points, like this, excluding the points on the perimeter. Convergent for all points in the region z minus z0 less than r. Less than r means all the inside points of the circle. Within the circle. And divergent for all points of the region, let us say z minus z0 greater than r, outside the circle. Then we can say that r is the radius of convergence. It is said to be the radius of convergence of the power series. And how to define? You defined it as, you can find it out by simply using this formula, limit n tends to infinity a n by a n plus 1. What is this an and n plus 1? An is this coefficient, okay na? So a2 and a3. So for higher values of n, you have to take the ratio of an and n plus 1 and put n equals to infinity to check the radius of convergence, to evaluate the value of radius of convergence. Is it clear, guys? Now if you have written down this, let's go for this problem. The value of the radius of convergence of the series is, so you are given already a series, you have to find out the radius of convergence. Do it. Look what you can do, since r is equals to limit n tends to infinity an by n plus 1, so you can say 1 by r is an plus 1 by n. So this is feasible to evaluate first. So you can calculate an plus 1, then n, take the ratio, put n tends to infinity, that will give you 1 by r. Then from 1 by r you can find out r also. Okay. This is a1, a1 is half, a2 is this thing, a1 is half, a0 to 0, a2 is this is your a3. So finding a pattern, you calculate an plus 1, then you find an, take the ratio. First find an. If you closely look at this term, third term is 1 3 5, second term 1 3, so 2 unit difference you see. In the denominator 2 5 2 5 8, 3 difference, 2 difference in the numerator, 3 difference in the denominator. So an, what do you expect it? 1 3 5, you see the third term it is coming 5, so 2 into 3 minus 1, है ना, 2n minus 1 if you write. For this n equals to 2, 2 into 2 minus 1, so this one you can write 2 5 8, so on. Here what we can write, 3n minus 1 if you write, so 3 into 3 minus 1 is 8, 3 into 2 minus 1 is 5, so this is matching, no? Can I write it n? So what will be an plus 1? Means you have to take one term extra, है ना? So this is up to an, and the next term we can easily write. Can you write or not? Each term is increased by 2 unit, 3, 5. So 2n minus 1 plus 2. So that will be 2n plus 1. Here each term is increased by 3 units. So 3n minus 1 plus 3. So 3n plus 2. Can it be written in this way? So if you take the ratio, let us say between an plus 1 and an, this is nothing but an times 2n plus 1 by 3n plus 2. So n plus 1 by n is equals to 2n plus 1 by 3n plus 2. No issue in this, in writing this. Okay. Therefore 1 by r, let us see we are calculating, limit n tends to infinity, an plus 1 by an, this is equals to limit n tends to infinity. If you take 2 common from the numerator, then it gives you n plus half. Or better, if you take 2n common, that will be more feasible for our calculation. We have to put n tends to infinity. So if you take 2n common, we get 1 plus 1 by 2n, and if you take 3n common, you get 1 plus 2 by 3n. So this n get cancelled, and if you put n tends to infinity, 1 by infinity is 0, 2 by infinity is 0. So you are getting 2/3, and hence r is 3 by 2, option C. Tell me if it is difficult. Very easy, na? If you know the formula, if you know the concept, then you can easily do it. So we are stopping here today. We will be continuing our discussion on Monday, and we will start from Taylor series. Then we will go for Lorentz series, then complex integrations, and this complex analysis, this is a huge topic. It will take couple of lectures to cover. Okay, before I end the session, let me tell you guys, for tomorrow's Sunday test 2, this is part of our test series and this course also. So tomorrow you will be having your Sunday test at maybe 9:30 a.m. in the morning. You can give it from laptop, mobile, everywhere, from website, app, and the syllabus, you know, I will relate to the precise syllabus. For the timing, you know, differential equation will be there. Did you consider special functions? We'll let you know in the group, okay, syllabus, but know that tomorrow we have a Sunday test. Please explain 2n plus 1 in division. Yeah, this is 2n plus 1. So if you take 2n common, what do you get? 1 plus 1 by 2n. And from the denominator, if you take 3n common, 1 plus 2 by 3n. Why we do this? Because we have to put the limit n tends to infinity. Now when you have 1 by 2n, if you put 1 by 2 times n tends to infinity, so it becomes 1 by infinity, that is 0. Similarly, 2 by 3n, if you put n equals to infinity, you get 2 by infinity, so that is 0 again. So this is a 0, this is 0, so we get 2 by 3. An plus 1. So an you understood, na? So an plus 1 is the next term. Like if I consider this a3, what will be your a4? a4 is 1 times 3 times 5. So it is increasing by 2 units, 1, 3, 5. So 7, 2, 5, 8, 11. Similarly, an is 2n minus 1. So n plus 1 next term will be in the numerator 2 units will increase. So 2n minus 1 plus 2. So 2n plus 1. So into 2n plus 1. In the denominator 3n minus 1 plus 3. So 3n plus 2. That is a 3n plus 2 we have written. Now up to this, it is already there in an. This part is an, na? So we have written an 2n plus 1 by 3n plus 2. Clear now? Okay, so let's end the session here, and you revise the topics, differential equation, maybe Fourier series, special function, all those, and give test tomorrow, and give the test seriously. If you miss 1 or 2 lecture, that you can compensate as soon as possible, but giving test is most important. Don't miss any Sunday test. If you make a habit of giving test regularly on every Sunday, then it will highly benefit you on the exam day. Trust me, this will benefit you like you can't even imagine how it is going to benefit you. With this note, let's end the session here. Bye bye. Take care, guys. Have a great day.